So this is the definition of a wave, a disturbance that travels through a medium transporting energy from one location. So to understand the basics of sound, we have to learn about waves. So there are two different types of waves, transverse and longitudinal. Transverse waves are waves where the vibrations are perpendicular to the direction of travel, and longitudinal waves are waves in which vibrations are parallel to the direction of travel. You can see on these diagrams even further how this movement is shown. And here we see the anatomy of a wave. So we can see that these points are the crest, and then these points here are the troughs. And then one wavelength is the length of a full cycle of a wave. And the amplitude is how far from the equilibrium or the position it extends. So frequencies are the number of complete waves to pass a point. And you can see how I've color-coded this diagram to show you different frequencies. So this shows you how to find one frequency. So since we're learning about the physics behind music, we will focus on longitudinal waves. So in a wave, particles of a medium are temporarily displaced and then return to their original position. So this shows you the definition of a medium in case you were wondering through the wave definition. And in longitudinal waves, particles of the medium are displaced in a direction parallel to energy transport. So here are some real-life examples of transverse waves. So waves in water for transverse. An example of a longitudinal wave is a slinky. So I printed out some pictures so you guys can see even further how that is so.
Hello everyone, this is Anna. So what you just saw is something called the oscillation of a guitar. When you plug a string on a guitar, it produces sound, but it also produces something called standing waves. What are standing waves? Standing waves are a combination of two waves which are moving in opposite directions. In order for this to happen, however, both waves must have the same amplitude or distance, and they must have the same frequency. This is caused by interference, which causes the waves to either combine energies or to completely cancel out. So what we'll be taking a look at in this other half of the video is how to actually find the speed of a wave as it travels through the string of a guitar. As I play the strings on the guitar, notice that the sound of each string changes as the string becomes thicker. Now this doesn't only have to do with the thickness of the string, it also has to do with the length of the string. For example, if I place a capo on the 5th fret, notice that the sound changes. Also, if I play a chord, for example, the sound also changes, and this is because I have different fingers on different strings on different frets as well. So this causes the strings to shorten, and it causes the vibrations to also either become longer or become shorter. And it does change the speed and the wavelength as well. So what is the actual equation in order to find the speed of the wave? The equation to find the speed of the wave is V equals F times lambda. What is this? So basically, speed equals the frequency of the wave multiplied by the wavelength.